Hello guys, so today we are going to study about uh, glycolysis. So first of all, before we begin, we need to understand what is glycolysis. So glycolysis is separated by two words, glyco and lysis. Glyco means glucose or sugar, glucose also known as sugar, and then lysis is the splitting or the breakdown. So glycolysis is the process of breaking down sugar. Alright, next. So before we begin, where does the source energy comes from? So the primary source of the energy is from the sun, the sun, or the sunlight. This is sunlight. Sun, and then it will transfer the energy, not transfer, but it, the the energy from the sun is being absorbed by the autotrophs, autotrophs, which is the plants, okay, the plants, and then the plants, which is the producer, producer, and hence the heterotrophs organisms such as cattle, cow, tiger, elephant will eat the plants. For example, if this one produces fruits, then the elephants will eat the fruits from the plants, so it gets the energy from the producer. This is the consumer, the elephant, get the energy from the autotrophs, which autotrophs are the plants undergo the process of photosynthesis to produce the food from the other organisms, animals. You need to understand, you need to know, you must know where does glycolysis occur. So glycolysis happens inside the cytosol, or also known as the cytoplasm of the cells. How many steps involved in the glycolysis? There are 10 steps. Next, what phase? We have two phases divided into the first phase, which is the step 1 until 5, is known as the energy investment phase, whereas another step from the 6 until 10 is the phase of energy payoff phase. In the step 1 until 5, the energy, which is the adenosine triphosphate ATP, is used. So ATP being used to activate, to make the molecules become reactive. And then from the step 6 to 10 is energy, the energy being produced. Okay. And then the next questions that arises from the topic glycolysis, or the basics, the fundamental, the general knowledge that you must know before you understand a study about glycolysis is you need to know how much energy is produced from this glycolysis. So the energy referring to the ATPs, there are 4 ATP produced from the glycolysis, but the net ATP will be 2 net ATP, 2 net ATP only, because 4 minus 2 we get 2. The balance is just only 2 because we use 2 and then we produce 4, we use 2, so 4 minus 2 balance, there are only 2 net ATP produced. Next, last questions. What are the products? Okay, this the products from the glycolysis. Of course, the first thing you will get, which is the ATPs or energy. You can say 2 net ATP, and you also get the NADH molecules, 2 NADH, which is the electron carriers. And the last one, of course, which is the main products that we are looking for, which is the pyruvic acid, 2-pyruvate or pyruvic acid. Pyruvic acid, also known as pyruvate. Okay, so let's begin. First of all, we have a glucose with a 6 carbon, a compound with 6 carbon, or a molecule with 6 carbon. So let me draw 2, 3, 4, 5, 6. So this is glucose. I will numbering from the left to the right. So this is the first, and this is the 6th carbon. Next, the glucose in the first step, what happened is this is first step. What happened here is the glucose is phosphorylated into the glucose 6-phosphate, which is also a 6 carbon molecule. So phosphorylated means here one phosphate, inorganic phosphate, is added on the 6th carbon of the glucose. So we'll draw the structure before and after. 1, 2, 3, 4, 5, 6. This is the 6th carbon. It's now being added or attached to a phosphate group. Yeah, make the structure look bigger, a bit bigger. Sorry. Okay. And then the first step is phosphorylated, catalyzed by the enzyme hexokinase. Okay, and then moving on to the next step, from the glucose 6-phosphate, it will become transformed into fructose 6-phosphate. So the keywords here we will use as the arrange. So from the glucose 6-phosphate, it is arranged into fructose 6-phosphate, which is the isomer. So they just arrange. So the structure remains same. 3, 4, 5, 6 remains same. The phosphate group still attached to the 6 carbon of the glucose 6-phosphate, and then so this is the second step. Second step, and then moving on to the next step, the third step here. So I forgot to mention the enzymes that had the arrangement from the glucose 6-phosphate into the fructose 6-phosphate is the possible glucose isomerase. So arrange, or another keyword can be used also, isomerization. Isomerize to A. And then from the fructose 6-phosphate, which is a 6-carbon compound, a 6-carbon molecule, it is catalyzed by the enzyme phosphofructokinase, also known as the PFK enzyme. This is a key enzyme, very crucial in glycolysis. It is become fructose 1,6 biphosphate. Instead, the one inorganic phosphate group is being added to the first carbon. So I will have here structure looks like this: 1, 2, 3, 4, 5, 6. This is the first carbon. You add another phosphate group here, and then this is the sixth carbon. The previous phosphate group remains still attached. So this is the third step, and then from the fourth step, the next step is the fourth step. Is the fructose 1,6 biphosphate will become the hydroxyacetophosphate DHAP, catalyzed by enzyme aldolase. So this compound DHAP, this molecule, is also 3 carbons. They just split here. So the left hand side, or the left part, is the DHAP, and the right side is the G3P. We'll look at this. I will draw the structure of the DHAP, one phosphate group attached to the first carbon, second carbon, and the third carbon. And then so what happened at the fourth step is the fructose 1,6 biphosphate is converted into the dihydroxyacetophosphate DHAP, 3 carbon molecules. They are splitted into two. Just the left part is this side is the DHAP, and then this side is the G3P. So this is the first, second, third carbon, and then this is first, second, and third carbon. So this explains why their name become G3P, because this is the first carbon, this is the second, and this is the third carbon. So the third carbon is connected, or is attached to the phosphate group. So that's why we call as G3P. And starting from here, the molecule will become extra, will become duplicated, will become two because a glucose is a 6 carbon molecule, so you will have two G3P. This is G3P. This so we have two G3P. And then for the glycerol dihydrophosphate, it is catalyzed by enzyme glycerol dihydrophosphate dehydrogenase will become the 1,3-bisphosphoglycerate, which is also a 3-carbon compound molecule. There are also two non-placed here. What happened here is the inorganic phosphate is making a new bond with the first carbon of the G3 piece. So you have like this. So these are the illustration for the structure of 1,3-bisphosphoglycerate. So this is this text. This is the 6th step, and then this is the 7th step. We just continue from the 1,3-bisphosphoglycerate. The phosphate group from the first carbon will break down. So that's why they become the 3-phosphoglycerate. This phosphate group will transfer to the ADP, adenosine diphosphate. So it will become ATP, adenosine diphosphate, to ATP, because there are two compounds of 1,3-bisphosphoglycerate. So this the 7th step is catalyzed by enzyme phosphoglycerate kinase, and then it will become 3-phosphoglycerate. So structure this one. This 5th group. And then from the 3-phosphoglycerate, which is a 3-carbon compound, so 2. It is phosphorylated by enzyme phosphoglycerate This is the 8th step. It will become 2-phosphoglycerate. Let's start the phosphate species for the second carbon. This is the second molecule. So what happened next in the next step? Step 9. The 2-phosphoglycerate is catalyzed by enzyme with the aid of enzyme amylase. It will transform and become into the phosphate inorganic PEPs, also to replicate of the compounds. And the compound looks like this. 1, 2, 3. Second carbon. 1, 2, 3. Okay. Second carbon. Phosphate group here starts to detach or breaks down from the 2-phosphoglycerate from the phosphate inorganic group. And then the last step, the step 10, the PEP will become the pyruvate, which is the final product of the glycolysis. So there are two. Thank you. Yep. This step is catalyzed by the enzyme pyruvate.
Dia 5 soalan. Ingat? 5 soalan. 25 markah.
Esok
5 soalan 25 markah.
banyaknya.
Short answer. Short answer pun. Topik yang mudah.
Pyruvate is sodium compound, 3 carbon, and then we are finished. This is the enzyme analysis. So step 1 anti-5 here. 1 is then this step is the energy investment phase. Because we use 1 ATP in the first step. Use 1 ATP use in the first step to phosphorylate to make the molecule become activated. And then at the third step, we use another ATP, 1 ATP is used. So total we use 2 ATPs. And then in the next step 6 until step 10, we produce we produce 2 ATP from the step 7, this, and then at the step 10 the phosphate group is breaking down from the PEP. So our final product, which is the pyruvic acid of pyruvate, will connect this first, second, and third one. First another pyruvate, the second, 1, 2, 3. So no more phosphate group here, no more. Because the adenosine diphosphate here, ADP, they are dating the phosphate group from the PEP, so they will produce another 2 ATPs here. So at the next step, so at the step 7, 7 and 10. We produce 2 ATP respectively. So 2 plus 2 will become 4 ATPs. Whereas step 1 until 5, we use only 2 ATP, 1 ATP from step 3, and another ATP from the so we use the ATP in the first step and 3 step in the step 3. Here 1 ATP used Okay. Step 3, when another ATP is used. From step 3, from step 1 to step 3. Step 3.